All right, let's get started. We're going to start a new topic today that is one of my favorites, and it's about radicals. And so we're going to introduce this terminology of radicals to you. But first of all, we got a couple of bell work problems. This takes us clear back to like chapter 1 or 2, where we were solving simple equations, and these happen to be two-step equations. So let's just kind of review. The first step would be to get rid of the addition or subtraction, which I've kind of illustrated there. So in the first one, we minus 8 from both sides. The second equation, we minus 3. The third equation, we minus 3. And the fourth equation, we minus 3. So in every case, our first step was to subtract a number from both sides in this particular group of equations. And then you can see the results. Now the next step is illustrated by this. We're going to divide both sides by whatever the number is and left by x. So if it's in front of x, we divide like this, divide both sides by 8. On this one, we divide both sides, the number that's left is underneath p. So in order to get rid of that number, we have to multiply both sides by that same number, which is illustrated here. And the same here, the number left under 12, we need to eliminate that to get x by itself. So we multiply both sides by 12. And when we do that, those numbers cancel each other out because they simplify to be just 1. And then our final answer ends up being 10 in the first problem, negative 3 in the second problem, negative 15 in the third problem, and the last one comes out to be x equals 12. All right, now we're talking about simplifying radicals, and these are the things that we call roots or square roots, cube roots, that type of thing. We've done a little bit with that so far, and we're going to pretty much stick to square roots in this class. We often simply simplify radicals to write them in a more understandable way and without those crazy decimals that sometimes make them irrational. So the objective is to understand and simplify radicals. So let's keep moving along here. All right, so the symbol that you can see here is that square root symbol that we've talked about before. It's called a radical sign, and it is used to represent a square root. Now, you don't need to get too caught up in some of these terminologies because we're not going to give you a spelling test or a vocabulary test on this, but we may refer to the radical sign or something like that. We just want you to know what we're talking about. The number under the radical sign is called the radicand. That's the number that we're trying to find the square root of. So in this case, the radicand is 2. All right, so a square root of a number is the number that when multiplied by itself equals that given number. So if on a calculator I find the square root of 5, it ends up being 2.236079, which it ends up being a rational number or a number that does not terminate or repeat. And on the other hand, in this next example, the square root of 6.25 equals 2.5. That is a decimal, but it happens to be a terminating decimal. So some of these square roots can either be irrational or they can be a terminating decimal. Now, a third type of square root is called a perfect square. It's a number with integers and no decimals as its square roots. For example, the square root of 4 just equals 2. So that's what we would call a perfect square. Let's practice finding a new square root to see what they're like. So when we crack these open, we notice that the first one, square root of 2, is equal to 1.4142562. And I put a couple of dots on there to indicate that this does not terminate or repeat, but just keeps on going. And the same for the square root of 3, 1.732050, and so on. However, these other two look more like perfect squares, and this is what I mean. When you find their square root, then you end up with some type of accounting number. So this really means that 2 times 2 equals 4. 3 times 3 equals 9. So that's what we're talking about. All right, are these numbers perfect squares? Well, let's find out. If we take the square root of a couple of them, we notice that the square root of 12 is a decimal that does not terminate or repeat, so it's not a perfect square. Square root of 42, another decimal that does not terminate or repeat, so it's not a perfect square. But if you look at these others, you can almost predict what their square root is going to be. For example, 4 times 4 is 16. 5 times 5 is 25. And so the others are 9 times 9 is 81, and 6 times 6 is 36. So those other 4 examples, yes, are perfect squares. All right, when you multiply a number by itself, you square the number. So that's where the squared comes from, is when you multiply it by itself. And it's kind of trying to indicate what it's like when you find the area of a square. You just multiply it by its length times its width, and that's how you end up with square. So like if you have a square like this, and it's 4 times 4, to multiply that together, it just gives you the area, and that's what we call 4 squared. Okay, so to undo this square root that we're talking about, or this squared number, then all you have to do is take its square root. So to take the square root of a number is the opposite of squaring it. Just like when you want to get the opposite of an addition, you subtract it. Well, these are inverses as well. So I want you to understand that to undo the square root of a number, you just square it. Okay? Okay, let's keep on moving. So another thing we need to understand is all real square roots of a number may not be positive. For example, on 25, I know that 5 times 5 does in fact equal 25. But can you think of 2 other numbers that are like 5 and 5 that also when you multiply together you get 25? Well, you do get -5 times -5. So it turns out that each number that has a square root has a positive and a negative square root that goes along with it. So that's something to kind of keep in mind. And I've kind of indicated that over here as well. Not just trying to do it twice, but that's kind of what we're talking about. So we usually use the positive square root 95 or 98% of the time, but it's important to note that there is a negative square root as well. And you'll probably have to find a couple of those. In fact, let's try a couple right now. Find all the real square roots of 36. Well, I happen to notice that that's a perfect square, so my square roots would be 6 times 6 and -6 times -6. And then this way of writing this means what number squared gives you 36? Well, -6 squared does, and so does +6. This next one would be 7 times 7, or -7 times -7. This next one would be 8 times 8, or -8 times -8. And then our last one, most of you know this one. This is just 10 times 10, and -10 times -10. All right, so that's what we're talking about when they saying that they all have actually 2 different square roots. Okay, so on Alex, you might get a problem that says, find all the real square roots of 36. If there's more than one answer, separate them with commas. So when you do the square root of 36, and you might use your calculator and do square root of 36, then what you end up doing is finding out that it's 6 times 6 and -6 times -6. So there's 2 real square roots of this, and so when you insert it in the box there, you will just do 6, comma, -6. And that will be your answer for a problem like that on Alex. All right, so let's try a couple more. Type, and here's another way where we will sometimes express what square root we're looking for. For example, if I just want the positive square root, and I just say, what's the square root of 16? And you'll tell me that it is 4. What if I want the negative square root of 16? Well, that would just be the -4 times the -4. So that's what we would consider the negative square root of 16. Now, keep in mind that negative is out in front of the 16. It's not inside the square root symbol. If you try to take the square root of the negative sign like this, it will actually give you an error message. So you can't put a negative sign in front of your number inside of the radical. It just doesn't work that way. Okay, square roots of perfect squares with signs. Evaluate the following. Well, this one, we just got to saying you couldn't put a negative in front of it, so this one is undefined. You can't do it. All right, so that's the first one, undefined or no solution. The next one wants the negative square root of 36, which would be just -6, because -6 times -6 equals 36. So there's the negative square root of 36. All right, let's practice a couple more. The negative square root of 121. Well, if you do that on your calculator, you'll end up finding out that the square root of 121 is 11 times 11. So the negative version of that would be a -11 times -11. For the square root of this negative sign is inside the radical symbol, so you can't do it. So no solution or undefined. All right, keep on going here. What about this one? Oh, the negative sign's inside again, so no solution. All right, so the last one, the square root of 324. Now that number is getting big enough that you probably better try that on your calculator, right? So you do that second x squared of 324 on your calculator, and you end up with the number 18. Now this did not ask for the negative square root like it did on the first one. It asked for the positive one, so it would be positive 18. Okay, how about on Alex? If you see a question like this on Alex, you're going to see one like this. It says, what's the negative square root of 100? Well, that's just -10. What's this? This would be, oh, and here's another way to express it. This is not a real number. So on that one, you'll just click it, stick it in there like that. Okay? All right, now there's one more here that we want you to understand. What if I have the square root of a fraction like this? That looks kind of scary and intimidating. Well, it's not at all. This is the same thing as asking this. What is the square root of 16 over the square root of 81? So you take each square root individually, and when you do that, you end up with 4 over 9. So that's your answer for that. Square root of 16 over 81 is just 4 over 9. So that's not hard at all. So let's try a couple more. Square root of 4 over 25, the positive square root of 4 over 25. Well, the square root of 4 is 2. The square root of 25 is 5. So that's the first one, 2/5. The next one, the square root of 16 is 4. The square root of 36 is 6. And that would simplify further to be 2/3. So you could put down either answer and that would be correct. This one, 9 over 100. The square root of 9 is 3. The square root of 100 is 10, at least the positive version of those square roots. And then the last one, the square root of 64, well, the square root of 64 is just 8. The square root of 9 is 3. So on that last one, you'd get 8/3. All right. So your assignment is going to be on Alex. It's called The Introduction to Radicals. Good luck getting familiar with these radicals. We've got several more things to show you about them, and I think you're going to like it.